Spring 1941. The North Atlantic. A British destroyer races through black water, hunting a phantom. Somewhere beneath the waves is a U-boat, a steel shark stalking a convoy of merchant ships carrying the food, fuel, and ammunition that's the only thing keeping Britain from starving. Inside the destroyer's bridge, the Aztec operator's voice crackles. Contact bearing 090, range 800 yards. The captain orders full speed ahead, 700 yards, 600, 500. The Aztec pings grow louder, faster, more urgent. 400 yards, 300, and then silence. The echo disappears. The submarine has vanished from the sonar screen, not because it's gone, but because the destroyer is too close. The physics of underwater acoustics have created a deadly blind spot. For the next 90 seconds, the crew is firing completely blind. The captain shouts orders. Depth charges roll off the stern. 20 seconds, 30, 40. Massive explosions erupt, shooting water columns skyward. But beneath the surface, the U-boat commander has used those 90 seconds of invisibility to turn hard left and dive. The depth charges explode where the submarine used to be. By the time the water settles, the U-boat is half a mile away, lining up a torpedo shot. This scene repeated thousands of times. The mathematics were brutal. 60 depth charge attacks for every 1 kill. The U-boats were winning. Britain was dying. And then a Canadian chemist who spent his childhood blowing up his friend's attic walked into the Admiralty and said, "You're doing it all wrong." Today we're telling the story of Charles Goodeve and the Hedgehog. How a man who studied how the IC's color ended up inventing the weapon that broke the back of the wolf packs. This is the scientist who sank the wolf packs. To understand this story, we have to meet Charles Frederick Goodeve. Born in 1904 in the small prairie town of Neepawa, Manitoba. He wasn't a naval officer. He wasn't a weapons expert. He was a scientist who had a lifelong habit of ignoring the word impossible. By 1940, at age 36, he was one of the world's leading physical chemists. When the war broke out, his commission in the Canadian Naval Volunteer Reserve was activated, and he was brought into a remarkable organization, the Department of Miscellaneous Weapons Development, better known as the Weasers and Dodgers. Their job? To solve the impossible. Goodeve looked at the statistics of the Atlantic War and saw disaster. Britain is an island. It cannot feed itself. If the U-boats cut the supply lines, Britain surrenders without a single German soldier landing on its shores. Winston Churchill later wrote that the only thing that ever really frightened him during the war was the U-boat peril. The problem was the Aztec, or sonar. It was revolutionary, but it had a fatal flaw. The sound beam projected forward at a fixed angle. Once the ship got within 300 yards of a submarine, the beam passed right over the target. This created blind time. For 90 seconds, the destroyer was just a loud, fast-moving target. The U-boat commander knew exactly when the ping stopped. That was his cue to escape. Goodeve realized that the depth charge, the pride of the Royal Navy, was a tactical failure. It was launched after the ship passed over the target. It gave the enemy a 90-second head start. Goodeve's idea was so simple it sounded stupid. Why don't we fire the weapons forward, while we still have sonar contact? Let's break down the tactical physics. Why was firing blind so ineffective? The math of the depth charge. Depth charges sink at about 6 to 9 feet per second. If a submarine is at 300 feet, it takes nearly 50 seconds for the charge to reach it. Add that to the 90 seconds of blind time while the destroyer is closing the distance, and the submarine has over 2 minutes to maneuver. In 2 minutes, a U-boat can be hundreds of yards away from its last known position. The sonar chaos. When a depth charge explodes, it creates a massive disturbance in the water. Bubbles, turbulence, and temperature layers. This scrambles the sonar picture for up to 15 minutes. Even if the escort survived the first attack, it couldn't find the sub again for a quarter of an hour. The U-boat used that chaos to vanish. Goodeve's solution was a multi-spigot mortar that would fire 24 projectiles simultaneously in a circular pattern. The tactical advantages were clear. Maintain contact. You fire at 300 yards while the sonar is still locked on. No blind time. The submarine doesn't get his 90-second window to turn. The contact fuse. Unlike depth charges that explode at a set depth, Hedgehog projectiles only exploded if they hit the submarine. This was the genius of it. If you missed, the water stayed calm. No bubbles, no sonar disruption. You could immediately fire again. You would think the Royal Navy would jump at this. They didn't. The British military establishment, specifically the Ordnance Board, hated the idea. Why? Because it used spigot mortar technology, which they had rejected 3 times over 30 years. An officer told Goodeve, if God Almighty himself sponsored the spigot mortar, it would still be turned down. The doing a Goodeve strategy. In the Navy, the expression to do a Goodeve became slang for getting something done by hook or by crook, bypassing every official channel. Goodeve ignored the committees. He ignored the proper procedure. He built a prototype using a musical instrument company, Boozy and Hawkes, because they could manufacture the precision parts he needed, crashing Churchill's lunch. By spring 1941, the project was stalled by bureaucracy. Goodeve knew he needed one person to see it: Winston Churchill. Goodeve heard Churchill was attending a different weapons demo at Chequers. He crashed the event without an invitation. When Churchill said he didn't have time because he wanted his lunch, Goodeve insisted it would take 3 minutes. The launcher fired 24 projectiles into the sky. They arched gracefully and landed in a perfect elliptical pattern. Churchill watched in silence, then asked for a second demo. The next morning, the First Sea Lord summoned Goodeve. Production was authorized. The bureaucratic wall had been smashed because a prime minister missed his lunch. The Hedgehog was 10 times more effective than depth charges. But the ultimate proof came not in the Atlantic, but in the Pacific, with a ship called the USS England. In May 1944, the England was assigned to hunt a Japanese submarine line. Most crews were still skeptical of the Hedgehog because it didn't make a big splash like a depth charge. If you missed, it was silent. It felt like failure. But the crew of the England trusted the science. The record was extraordinary. May 19, they detect I-16, 5th Hedgehog attack. Cataclysmic detonations. Submarine destroyed. May 22nd. They find RO-106. 3 Hedgehog hits. Submarine gone. May 23rd, 24th, 26th. They sink 3 more. The stand. On May 31st, other ships had been hunting RO-105 for 30 hours, missing with every depth charge. The England arrived, fired 1 Hedgehog pattern, and the submarine was obliterated. 6 submarines in 12 days. It is a record that has never been matched in naval history. Admiral Ernest King sent a message to the fleet. There will always be an England in the United States Navy. The Hedgehog had turned the hunter-killer group into a surgical instrument. What are the takeaways from the story of Charles Goodeve? First, the tactical advantage of constant tracking. In warfare, the blind spot is where you lose. By eliminating the 90-second gap, Goodeve took away the U-boat's only defense: invisibility. Second, the scientific method versus military tradition. Goodeve wasn't burdened by how we've always done it. He looked at the data. He saw that 60-to-1 was a failing ratio, and worked backward to a solution. Finally, the importance of the outsider. The Hedgehog only exists because a chemist who studied color perception was willing to fight his own side's bureaucracy as hard as he fought the enemy. The Atlantic was won in the North Atlantic gales, but it was also won in the beakers and slide rules of Nipawa's most famous son. Charles Goodeve died in 1980, a knight of the realm and a hero of science. The next time you see a modern anti-submarine weapon, like the ASROC or the Limbo, remember that they all traced their lineage back to that 24-spigot Hedgehog mortar. They told him it was impossible. They told him it was rejected. They told him to wait for the committees. He built it anyway. And in doing so, he saved the convoys, he saved Britain, and he changed the course of the war. If you found this tactical analysis of the Hedgehog valuable, subscribe to WW2 Battlegrounds. Here's a question for you. If you were in charge of the Royal Navy in 1941, would you have trusted a chemist with no naval experience to change your entire anti-submarine doctrine? Share your thoughts in the comments. Next time, we're looking at the secret war of the magnetic mines, Goodeve's first great challenge. Until then, this is WW2 Battlegrounds, where history meets strategy.